sorry, two circles with radii 25 centimeter and 9 centimeter touch each other externally. You can see I have made them touch each other externally. Find the length of the direct common tangent. So what is the direct common tangent? Direct common tangent will be like this, which touches both the circle at a point here. So this is not proper. I'll just make it like this. We have to find which length? We have to find the length of the direct common tangent. We have to find the length.
So from there to okay, got it.
Okay, we have to find this. Now it will have a center. If since there is a circle, it will have a center. This also will have a center. Very good question that you get in your exam. Now how to do it? We will have to draw radii in it. So I will draw the radii here. Construction in red color. Fine. And then I'll draw another radii from here. Come on. Sure. So difficult. Okay, it doesn't look proper, so I need to slightly shift it here this way. Okay, fine. So center is over here. This is not the center. Come on, yeah. Center is here. Fine. Since there are common tangents here, right? And they have given the radius also. So the radius is, this is the circle with the radii 25 centimeter and 9 centimeter. So one of those is 25 centimeter, this is 25 centimeter, and this is 9 centimeter. We have to find this length. Let it be, if I take it as what? A, let it be B, and let it be C, let it be D. So we have to find AB as a length. Okay.
So construction of D that produces a line up to AC such that AB is parallel to that line.
Okay, we have to think why we would be doing it here. So what is the reason for the construction?
So first we can prove it as a rectangle.
Okay, if I join the two radii here, will it be a rectangle? Let's see. Because the centers are, see, if I see these two circles, right, it doesn't look like a rectangle, and it doesn't form a parallelogram as well. So if it doesn't form a parallelogram, then it's difficult to find. Is that okay? So the only way we can find it out, okay, is what? By if I draw a line parallel to AB, either it becomes a parallelogram or rectangle. It will not become a parallelogram because if this angle is 90 degree, obviously it will be a rectangle in this case. Basically we need a parallelogram that will help us. Or
so we'll draw that construction, then by Pythagoras theorem we'll find that line, then we'll prove that it's a rectangle, and then opposite sides are equal, we'll find it.
So let's see here, we will draw a line parallel to this one here. I'll just draw it properly. It doesn't look proper. Alright, so I have drawn this as a construction. Now if I know this length here, all of you, if I know this length, let it be intersecting somewhere at E, for example. If I know the length DE, so DE will be equal to AB. But how to know DE? Right, if I
prove so that it'll become 90 degrees, it'll become a right angle triangle, then by Pythagoras theorem we can find.
Okay, here they have,
no we can't.
Here they have given you that these two are tangents. So we know that tangents are always at 90 degree, right?
Sir.
And if I prove that AEDB is a rectangle, then AB will become equal to ED, and AE will become equal to BD, because it's a rectangle, they will be equal. So if this is 9 centimeter, this also will be 9 centimeter,
Yes, sir.
right? From here
Yes,
to
sir.
here will 9 centimeter. Total is 25, so this length is going to be how much?
14.
25 minus 9 is how much?
Oh, sorry, 16. 16.
16 centimeter. This length is 16 centimeter, right? And this is 16 centimeter, and this is 16. They have not given anything else. Two circles radii 25 and 9 touch each other. So we know this length from here to here is how much? 25. And from here to here is how much? 9 centimeters. So do we know the entire CD? The entire CD will be how much? 25 plus 9? 34 centimeter. Clear? So in this triangle, okay, and if it is a rectangle, if I prove, then this angle is 90, this angle is also 90 degrees. So we got triangle ECD as a right angle triangle. And if ECD is a right angle triangle, then we have got the hypotenuse as 34 centimeter, and one of the perpendicular side is 16 centimeters. So we can find the other one, that is ED we can find, and once we find ED, then AB is known to us. So right, we can say construction. What is the first construction there? Construction is, right, what is the first construction? That we will join AC, join the following here. AC, AB is already there, right? AB was already there. You'll join AC and say BD, the centers are there, fine, and we will draw a perpendicular DE, right? Perpendicular DE. Okay, it's not perpendicular DE. Okay, I'll draw DE. DE perpendicular on AC. Is that okay? Fine. And also join CD. Also CD. So we have, okay, these are the three things we will do. AC, BD, perpendicular, okay, on AC, D as a perpendicular on AC, and join CD here. All of these have to be done. After that, we have to prove that EDBA is a, or AEDB is a rectangle. So we know that angle A is equal to angle B, right? Right, and they are equal to 90 degree, being tangent. They are tangents here. Fine. So know the tangent subtend equal 90 degree with the center of the circle. The line joining the center of the circle. We have a theorem for it. And two perpendiculars are parallel to each other. So these two lines are parallel to each other. Fine. Since we have drawn a perpendicular here, the third angle is also a perpendicular on it. Then fourth will automatically be a perpendicular 90 degree, because sum of all the four angles is 360 degree. So fourth angle will automatically become 90 degree here. So we can say AEDC, sorry, okay, we can write here angle AED is equal to 90 degree. This is by construction. Then angle EDB will be 90 degree. You know how? Angle sum property of quadrilateral. Understood? Angle sum property of quadrilateral, it will become 90 degree. Is that okay? So if all the angles of a quadrilateral are, each of the angle is 90 degree, then we can say quadrilateral AEDB is a rectangle. It is a rectangle. And if it is a rectangle, then what will happen? It means
Opposite sides.
AB is going to be equal to ED. And now if I find ED is done, so I'll go to the triangle now. So where? In triangle CED, right? They have given you CD is 25. I'll not write here, I will write it below. CD is going to be equal to 25 plus 9, because the two circles are touching each other. And let it be, say if I take it as M, so we can write CD here is equal to CM plus DM, right? So this is why 25 plus 9, that is equal to 34 centimeter. CD, we got it here. Now AC is equal to EC plus AE. So AC is how much? 25 they have given you, right? Is equal to EC is how much? EC is to be calculated, and AE is how much? 9 centimeter. Why is it 9 centimeter? Because AE is equal to, I have to write here, AE is equal to DB, opposite sides of rectangle. So EC will be equal to 25 minus 9. So EC is how much? 16 centimeter. We got this one as well. So if we have the two sides of the triangle given, we have to find a third one. So which is the third one now? I'll come back. So using Pythagoras theorem, we can write EC square plus ED square is equal to CD square. EC square, EC is how much? 16. So 16 square plus ED is how much? ED is to be found out, is equal to CD is how much? 34 square. So ED square is equal to ED square is going to be 34 square minus 16 square. To make it simple here, ED square will be equal to 34 plus 16 and 34 minus 16 here. Use the property. So ED square is equal to 34 plus 16 is how much? 50. And the other one is 34 minus 16 is how much?
18, sir, become 900.
So ED square is equal to 900. So ED is equal to 30 centimeter. So we got ED as 30 centimeter. So ED is 30 centimeter and ED is equal to which one? AB.
So ED.
AB, right? So is equal to 30 centimeter. And this is an answer here. So we got the the length of this particular tangent is how much? 30 centimeter. And this is your answer. Is that understood or not? All of you, is it understood?
Yes, sir.
Who is sleeping now? Anyone sleeping? Okay.